Grumman, manufacturer of the LM, assigned a team of University of Toronto engineers, led by senior scientist Bernard Etkin, to solve the problem of how much air pressure to use to push the modules apart. The LM re-entered Earth's atmosphere and was destroyed, the remaining pieces falling in the deep ocean. Apollo 13's final mid-course correction had addressed the concerns of the Atomic Energy Commission, which wanted the cask containing the plutonium oxide intended for the SNAP-27 RTG to land in a safe place. Apollo 13's shallow re-entry path lengthened this to 6 minutes, longer than had been expected. Controllers feared that the CM's heat shield had failed. En route to Honolulu, President Nixon stopped at Houston to award the Presidential Medal of Freedom to the Apollo 13 mission operations team. Worldwide interest in the Apollo program was reawakened by the incident. Television coverage was seen by millions. President Nixon canceled appointments, phoned the astronauts' families, and drove to NASA's Goddard Space Flight Center in Greenbelt, Maryland, where Apollo's tracking and communications were coordinated. The rescue received more public attention than any spaceflight to that point, other than the first moon landing on Apollo 11. Pope Paul VI led a congregation of 10,000 people in praying for the astronauts' safe return. 10 times that number offered prayers at a religious festival in India. An estimated 40 million Americans watched Apollo 13 splashdown, carried live on all 3 networks, with another 30 million watching some portion of the 6.5-hour telecast. Jack Gould of the New York Times stated that Apollo 13, which came so close to tragic disaster, in all probability united the world in mutual concern more fully than another successful landing on the moon would have. Immediately upon the crew's return, NASA Administrator Payne and Deputy Administrator George Lowe appointed a review board, chaired by NASA Langley Research Center Director Edgar M. Courtright and including Neil Armstrong and 6 others, Note 5, to investigate the accident. The board's final report, sent to Payne on June 15, found that the failure began in the service module's number 2 oxygen tank. Damaged Teflon insulation on the wires to the stirring fan inside oxygen tank 2 allowed the wires to short-circuit and ignite this insulation. The resulting fire increased the pressure inside the tank until the tank dome failed, filling the fuel cell bay with rapidly expanding gaseous oxygen and combustion products. The pressure rise was sufficient to pop the rivets holding the aluminum exterior panel covering Sector 4 and blow it out, exposing the sector to space and snuffing out the fire. The detached panel hit the nearby high-gain antenna, disabling the narrow beam communication mode and interrupting communication with Earth for 1.8 seconds while the system automatically switched to the backup wide beam mode. The sectors of the SM were not airtight from each other, and had there been time for the entire SM to become as pressurized as Sector 4, the force on the CM's heat shield would have separated the 2 modules. The report questioned the use of Teflon and other materials shown to be flammable in supercritical oxygen, such as aluminum, within the tank. The board found no evidence pointing to any other theory of the accident. Mechanical shock forced the oxygen valves closed on the number 1 and number 3 fuel cells, putting them out of commission. The sudden failure of oxygen tank 2 compromised oxygen tank 1, causing its contents to leak out, possibly through a damaged line or valve, over the next 130 minutes, entirely depleting the SM's oxygen supply. With both SM oxygen tanks emptying, and with other damage to the SM, the mission had to be aborted. At NAR's facility, oxygen tank 2 had been originally installed in an oxygen shelf placed in the Apollo 10 service module, SM-106, but which was removed to fix a potential electromagnetic interference problem and another shelf substituted. During removal, the shelf was accidentally dropped at least 5 centimeters, because a retaining bolt had not been removed. The probability of damage from this was low, but it is possible that the fill line assembly was loose and made worse by the fall. In November 1968, the shelf was reinstalled in SM-109, intended for Apollo 13, which was shipped to KSC in June 1969. The countdown demonstration test took place with SM-109 in its place near the top of the Saturn V and began on March 16, 1970. During the test, the cryogenic tanks were filled, but oxygen tank 2 could not be emptied through the normal drain line, and a report was written documenting the problem. After discussion among NASA and the contractors, attempts to empty the tank resumed on March 27. When it would not empty normally, the heaters in the tank were turned on to boil off the oxygen. The thermostatic switches were designed to prevent the heaters from raising the temperature higher than 27 degrees Celsius, but they failed under the 65-volt power supply applied. Temperatures on the heater tube within the tank may have reached 540 degrees Celsius, most likely damaging the Teflon insulation. The temperature gauge was not designed to read higher than 29 degrees Celsius, so the technician monitoring the procedure detected nothing unusual. This heating had been approved by Lovell and Mattingly of the Prime crew, as well as by NASA managers and engineers. Replacement of the tank would have delayed the mission by at least a month. The tank was filled with liquid oxygen again before launch. Once electric power was connected, it was in a hazardous condition. The board found that Sweigert's activation of the oxygen tank 2 fan at the request of Mission Control caused an electric arc that set the tank on fire. The board conducted a test of an oxygen tank rigged with hot wire igniters that caused a rapid rise in temperature within the tank, after which it failed, producing telemetry similar to that seen with the Apollo 13 oxygen tank 2. Tests with panels similar to the one that was seen to be missing on SM Sector 4 caused separation of the panel in the test apparatus. For Apollo 14 and subsequent missions, the oxygen tank was redesigned, the thermostats being upgraded to handle the proper voltage. The heaters were retained since they were necessary to maintain oxygen pressure. The stirring fans, with their unsealed motors, were removed, which meant the oxygen quantity gauge was no longer accurate. This required adding a third tank so that no tank would go below half full. The third tank was placed in Bay 1 of the SM, on the side opposite the other two, and was given an isolation valve that could isolate it from the fuel cells and from the other two oxygen tanks in an emergency and allow it to feed the CM's environmental system only. The quantity probe was upgraded from aluminum to stainless steel. All electrical wiring in Bay 4 was sheathed in stainless steel. The fuel cell oxygen supply valves were redesigned to isolate the Teflon-coated wiring from the oxygen. The spacecraft and mission control monitoring systems were modified to give more immediate and visible warnings of anomalies. An emergency supply of 19 liters of water was stored in the CM, and an emergency battery, identical to those that powered the LM's descent stage, was placed in the SM. The LM was modified to make transfer of power from LM to CM easier. Devices were placed in the S2 second stage to counteract pogo oscillations. On February 5, 1971, Apollo 14's LM, Antares, landed on the Moon with astronauts Alan Shepard and Edgar Mitchell aboard, near Fra Mauro, the site Apollo 13 had been intended to explore. Hayes served as Capcom during the descent to the Moon, and during the second EVA, during which Shepard and Mitchell explored near Cone Crater. None of the Apollo 13 astronauts flew in space again. Lovell retired from NASA and the Navy in 1973, entering the private sector. Zweigert was to have flown on the 1975 Apollo-Soyuz test project but was removed as part of the fallout from the Apollo 15 postal covers incident. Hayes was slated to have been the commander of the cancelled Apollo 19 mission, and flew the Space Shuttle approach and landing tests before retiring from NASA in 1979.